Hi everyone, welcome back in your own YouTube channel Vinay Magic Maths. Myself Vinay, the mathematics mentor. Hope you guys are doing much amazing. So let's proceed in ongoing videos of parabola. So let's see our today's goal. So first of all, we will start with line and parabola. We will see different cases of line and parabola which are possible. After that, we can see different forms of equations of tangents. And after that, we can see questions practice as well as we will see some of the questions that has already been asked in JEE Mains, right? So let's proceed with line and parabola. So our first topic is line and parabola. So what happens if we will be having a parabola? So let's say y square equals to 4ax and we will have to draw a line. Then what are the possible cases that are possible? So let's see, if I'm drawing a parabola, y square equals to 4ax. So let's see, equation of parabola is y square equals to 4ax. Now if I have to draw possible cases of line, so there will be three possible cases. Let's see the case 1. Let's see, this is line L1. So we can see this line is never touching or cutting the parabola at all. Case 2. So let's draw case 2. At this point of time, this line is touching parabola at single point. That's why this is known as tangent. So whenever a line will touch the parabola or any curve at distinct single point, that means that line will be known as tangent of that curve. So the third case possible can be line L3. This is known as line L3 and it is cutting parabola at two distinct points. So this is known as secant. So let me revise once again. The case 1, which is never touching or cutting the parabola at all. The case 2, that is line L2, it is touching the parabola at single point. That's why this is known as this is known as tangent of the parabola. And the case 3, that is line L3, this line is cutting parabola at two distinct points. That's why this is known as secant. So now let's talk mathematically. We are having the equation of parabola as y square equals to 4ax. Now let's assume equation of line to be y equals to mx plus c, the standard equation of line in slope and slope-intercept form. So we are having equation of parabola as y square equal to 4ax and equation of line as y equals to mx plus c. Now what happens if we will solve this simultaneously? So let's see. Putting the value of y equals to mx plus c in equation 1, we will observe mx plus c whole square is equals to 4ax. Now open this square. So we will get here m square x square plus 2mcx plus c square minus 4ax equals to 0. If we will rearrange it, we can write it as x squared in bracket m square plus taking x as common, so we will get 2mc minus 4a plus c square is equals to 0. Now we can see this is a quadratic equation in x, and if we are having a quadratic in x, then there will be two possible cases. Either roots will be real or roots will be imaginary. So in that case, so two cases are possible. Real roots will exist here, or imaginary roots will be there. Real roots or imaginary roots. So in case of real roots, we are aware that there can be two possible cases. Either roots will be equal and repeated, or two distinct roots will be there, right? And in case of imaginary roots, it is d less than 0. That is, there will be no real roots. So if d is equals to 0, it means this is known as condition of tangency, because we can see if there is a single root between line and parabola, it means the line will touch the parabola at single point. That's why this is known as tangent, and this is the condition of tangency. So d equals to 0 is known as condition of tangency. That means there will be single roots. There will be single common root between line and parabola. That is, it will be a tangent. In d greater than 0, it means line is secant. Line is secant. That is, line will cut the parabola at two distinct points, point 1 and point 2. That is, line L3 will be the example in this case, and d equals to 0, line L2 will be the example. And here d less than 0 means there will be no real roots at all between line and parabola. That means they will never intersect or they will never touch. That means line L1 is the example, and in this case, line lies outside of parabola. Line lies outside of parabola. Line lies outside of parabola. So now we got the condition of tangency, that is d is equals to 0. So these are the all possible three cases in case of line and parabola. That means, let me once again revise you. So we have the topic name is line and parabola. If we will have the parabola as equation of parabola as y square equals to 4ax, and we are asked to draw the lines, so there will be three possible cases. Case 1, line L1 will never touch or cut the parabola at all. Case 2, line will touch the parabola at single point. That's why this is known as tangent. And line L3, that is case 3, line will cut the parabola at two distinct points. That means this is known as secant. And if you will take this length of this, the length which is in between parabola, that will be known as chord, right? So let's talk mathematically. So we are having the equation of parabola as y square equals to 4ax and the equation of line as y equals to mx plus c. If we will solve this simultaneously, we will get quadratic in x, and we know that if we are having quadratic in x, in that case there will be two possible cases. Roots will be real or imaginary. In case of real roots, d equals to 0, that means there will be single root, that is the condition of tangency, line L2. In case of d greater than 0, it means line is secant, that is line will cut the parabola at two distinct points, point 1 and point 2. Similarly, in case of imaginary roots, d less than 0, that is line and parabola will never intersect or cut at all. It means line lies outside the parabola. So we got the condition of tangency, that is d equals to 0. It is a very important condition. So as of now, we have seen d equals to 0 is going to be the condition of tangency in case of line and parabola. So let's assume we have parabola y square equals to 4ax. We are having the parabola y square equals to 4ax. And you will observe that in parabola, we will see most of the useful results or derivations to be performed on y square equals to 4ax. So this is the standard equation of parabola, and we will see most of the results on this equation itself. So we have equation of parabola as y square equals to 4ax, and if you have to write the equation of tangents, so this is our tangent. In that case, we will be having one single point of intersection between line and parabola. So equation of parabola will be, so let's see our first form as normal form of tangent. Normal form. So let's say our first form as slope form of tangent. So here we will observe equation of tangent to be, so let's see y square equals to 4ax is the equation of our parabola, and we are having the, let's see, equation of line as y equals to mx plus c as our equation of tangent. Now we will solve this simultaneously and we will observe the results. So let's see what is going to happen here. So we'll put the value of y equals to mx plus c in first equation number 1. So we can write it as mx plus c whole square is equals to 4ax. Right? From here we can expand and write m square x square plus 2mcx plus c square minus 4ax is equals to 0. Now from here we can rearrange it as x square times m square plus, we'll take the x as common, we can write from here 2mc minus 4a plus c square equals to 0. This is the quadratic equation in x. So now there can be two possible roots, x1 and x2. So in case of, we have seen in case of tangent, we need to put d equals to 0 for this quadratic because there will be single point of intersection between line and parabola. So condition of tangency is d is equals to 0. So now b square minus 4ac equals to 0 for this quadratic equation. In this case, b equals to 2mc minus 4a and a is m square, c is c square. So now from here we can write 2mc minus 4a whole square minus 4 times m square c square equals to 0. We will simplify it as 4m square c square minus 16mca plus 16a square minus 4m square c square is equals to 0. This will get cancelled out. From here we can write 16mca is equals to 16a square. After simplification we can write from here 16 will get cancelled out and a will also get cancelled out from this. So mc is equals to a, that means c is equals to a upon m. This is a very useful result because from here we observe that c, the intercept form of this line slope intercept form of equation of line. From here we can see the value of c equals to a upon m if this line has to be the tangent on this parabola. So from here we observed that condition of tangency as c equals to a upon m. This is very useful result. You should always remember this result in case of line and parabola. For line to be tangent, we should write c equals to a upon m. So now let's see the equation of tangent, that is slope form of tangent. So we have observed that c equals to a upon m. It means equation of tangent will be, so equation of tangent will be, so we have assumed equation of tangent as y equals to mx plus c. So now we have observed that c equals to a upon m. That means we can write y equals to mx plus a upon m as the equation of tangent. So this is equation of tangent on parabola y square equals to 4ax. So this is the slope form of tangent. That means if we will have the slope of any tangent, so we can easily write the equation of tangent on that parabola by using this equation y equals to mx plus a upon m. So we have seen the derivation for slope form of tangent. If the point of intersection of line and tangent is given as x1 comma y1, if we are aware about this point and we need to write the equation of tangent, so we can write, and this form is known as Cartesian form of tangent. Cartesian form of tangent. So what we have to do in this case, replace x square with x1, y square with y1, x with x plus x1 upon 2, and y with y plus y1 upon 2. And apart from this, we can replace xy with xy1 plus y into x1 divided by 2, right? So if you have to write equation of tangent on any curve, right, on any curve, and we have been given the point on the same curve, so in that case, if you have to write the equation of tangent, so we can use the result t is equals to 0, and in order to write this t equals to 0, we need to substitute x square with xx1, y square with yy1, and x with x plus x1 upon 2, and y with y plus y1 upon 2, and xy with xy1 plus yx1 upon 2. So in case of parabola, so we have equation of parabola as y square equals to 4ax. We will take every terms towards left side, so we can write y square minus 4ax equals to 0. Now we have to write the formula t equals to 0. So how we will do this? We will write t equals to 0. In order to obtain t equals to 0, so we need to substitute. Now let's see here, from y square we can write y1 minus 4a, for x we can substitute with x plus x1 upon 2. So we can write x plus x1 divided by 2 is equals to 0. So this is t equals to 0. Now we will simplify it. We can write y1 minus 2a times x plus x1 equals to 0. So this is the equation of tangent on parabola y square equals to 4ax if x1 y1 is the point lying on the parabola, right? So this is the equation of tangent, and this is known as Cartesian form of tangent. Cartesian form of tangent. Equation of tangent, or we can say equation of tangent at point P. Equation of tangent at point P with coordinate x1 comma y1 on parabola y square equals to 4ax. So let me again summarize this. If we are having any curve and we need to write, and we have a point on the same curve, then we can use the result t equals to 0 to write the equation of tangent. What we have to do, we have to replace x square with xx1, y square with yy1, x with x plus x1 upon 2, and y with y plus y1 upon 2, and xy term with xy1 plus yx1 upon 2 of the given curve. So from there we can write t equals to 0. In case of y square equals to 4ax, we can write y square minus 4x equals to 0. To write t equals to 0, we need to substitute y square with yy1 and x with x plus x1 upon 2. From here we got the result as yy1 minus 2a times x plus x1 equals to 0. So this is the equation of tangent at point P x1 comma y1 on parabola y square equals to 4ax. So this is the Cartesian form of tangent. So now let's see another form, that is parametric form of tangent. The third form will be parametric form of tangent, and it is also very important. So to write the parametric form of tangent, we need to assume a point P on the parabola as at square comma 2at in case of y square equals to 4ax. As we have already seen the parametric coordinates, how to write parametric coordinates on how to take the parametric coordinates on parabola, right? We've already seen this. So to assume any point P on the parabola, we can write 80 square comma 280 in case of parabola y square equals to 4ax. We have seen this in last video. If you haven't seen this, you must watch those videos so as to gain better practice and better confidence, right? So now the third point is parametric form of tangent. Parametric form of tangent. So we have been given the equation of parabola as y square equals to 4ax, right? We can take the help of other two cases which we have seen here, or we can write this way. We can differentiate it on both sides. So we can write 2y y dash is equals to 4a times 4a. That's it. So from here we can write y dash equals to 2a upon y. Since y dash is nothing but slope of tangent, it will be 2a upon y. So we have observed slope of tangent as 2a upon y. So now if we are having a point P as 80 square comma 280 lying on the parabola itself, so in that case we can write the slope of tangent from point P as 2a upon y coordinate is 280. So it is nothing but 1 upon t. So we have observed slope of tangent as 1 upon t, where t is the parameter. Now we need to write the equation of tangent at point P. So we can easily write equation of tangent at point P 80 square comma 280. So from here we can write y minus 280 is equals to slope of tangent is 1 upon t x minus 80 square, and we can rearrange it as ty minus 280 square equals to x minus 80 square. Again we can rearrange it as ty equals to x plus 80 square. Ty equals to x plus 80 square. This is also going to play a very important role in case of solving questions on parabola. If we have the parabola as y square equals to 4ax. So always keep in mind that you have to use this result ty equals to x plus 80 square as equation of tangent on parabola only if the equation of parabola is y square equals to 4ax. In other cases, we will see how to tackle with the problems. So in case of y square equals to 4x, we need to assume the equation of tangent as ty equals to x plus 80 square, where t is the parameter. So we have seen the three different forms of writing equations of tangent on parabola y square equals to 4ax. So let me summarize once. So first of all, we have seen the slope form of tangent, where we have seen y equals to mx plus c. We have assumed y equals to mx plus c as the equation of tangent on parabola y square equals to 4ax. So in that case, we have solved line and parabola, and we have observed that condition of tangency as c equals to 0, and from there we have obtained the result as c equals to a upon m. So it means our equation of tangent will be y equals to mx plus a upon m. In second case, we have seen the Cartesian form of tangent. If we are given a parabola as well as any point lying on the parabola itself, so we can use the result t equals to 0, and we have seen we need to substitute x square with xx1, y square with yy1, and x with x plus x1 upon 2, y with y plus y1 upon 2, and xy with xy1 plus yx1 upon 2. So from there we have seen we can easily write the equation of tangent. And the third case is parametric form of tangent. In case of parametric form of tangent, we need to assume any point P on parabola. That is, in case of y square equals to 4x, we have already seen to assume any point on parabola. If we need to assume any parametric coordinates on parabola y square equals to 4x, then it will be 80 square comma 280. So simply we have find the slope of tangent as 2a upon y. From here we got slope of tangent as 1 upon t, and we can write the equation of tangent y minus 280 equals to slope x minus 80 square, and from there we have obtained the result ty equals to x plus 80 square. So these are the three forms of tangents. So let's see highlights of tangents. We will see how many tangents are possible in different scenarios. So for example, if we are having a parabola y square equals to 4ax and we are having a point P h comma k. So let's see, let tangent of equation. So let's tangent y equals to mx plus a upon m pass through the point P h comma k. There are three different scenarios. In case 1, if point P lies outside of the parabola. So how we will observe that point P lies outside the parabola? Since we have the equation of curve as y square equals to 4ax, we will call it as S1. So we will substitute the value of h comma k in this curve, in this equation, and if S1 is positive, that means once we will put the value of x and y coordinate into this equation, and we observe that S1 is greater than 0, it means positive, then it means that point lies outside the parabola. So in that case, there will be two different tangents are possible, as we can see in the diagram. from point P, which is lying outside the parabola, we can see two different tangents are drawn, right? In second scenarios, point P h comma k with coordinates lies on the parabola. How to check whether point P lies on the parabola? So we'll put the value of x and y coordinates of that point P into the parabola's equation, y square equals to 4ax. From there we can see it will becomes 0, that is s1 equals to 0. So if point P lies on the parabola, in that case there will be one tangent possible. So in, let's see case 3. So if point P h comma k lies inside the parabola, to check whether point lies inside the parabola, again we'll put the coordinates of h comma point P h comma k into the equation, and there we will see its values coming as negative. So s1 will be less than 0. So if point P lies inside the parabola, in that case there will be no possible tangent. So in second case we will see if point P lies on the parabola, in that case there will be one possible tangent. This will be the possible tangent. In third case, if point P lies inside the parabola, somewhere like this here, h comma k, so there will be no possible tangent in this case. So these are the highlights of tangents. Also we have seen how to check the position of point with respect to parabola. So let me again summarize. So if once we will substitute the value of h comma k into the equation of the given parabola, if we observe that s1 is greater than 0, it means point lies outside the parabola. If s1 equals to 0, it means point lies on the parabola. If s1 is less than 0, it means point lies inside the parabola. So if point P lies outside the parabola, as we can see here, there are two possible tangents that can be drawn. If point P lies on the parabola, as we can see here, only single tangent can be drawn on this, in this case. And if point P lies inside the parabola, in that case there will be no possible tangent at all. So we will use these results in solving the questions. So let's start with the questions practice. Our first question is, find equation of tangent to parabola y square equals to 12x passing through point P 2, 5. So we have been given equation of parabola as y square equals to 12x. So we are having equation of parabola as, let's draw a rough sketch. So equation of this parabola is y square equals to 12x, and we have been given a point P 2, 5. So we don't know point P lies on the parabola inside or outside. So let's check this. So we have equation of parabola as s1 is y square minus 12x. Now put coordinates of point P into the equation. So we can write this s1 as s1 equals to y square means 5 square minus 12 into x coordinate is 2. So on simplification we can write 25 minus 24. This is s1 equals to 1, which is positive. S1 is positive. If s1 is positive, we have seen in this case point P will lies outside the parabola. So let's see, point P 2, 5 will lie something here. Point P with coordinates 2, 5. So we know if point P lies outside the parabola, in that case we can draw two possible tangents. We can have two tangents in this case. So let's write the equation of tangent as y equals to, let's assume equation of tangent as y is equals to mx plus a upon m. We have seen the derivation. In this case, c is equals to a upon m in case of once we need to write the equation of tangent in case of parabola y square equals to 12x. So now our point P will pass through this through this equation. So it means 5 equals to 2 into m plus a upon m. From here, once we will simplify it, 5 equals to 2m square plus a, and we can write the value of a by comparing with the standard equation. We have a standard equation of parabola as y square equals to 4ax, and we have been given y square equals to 12x. From here we can compare and write a is equals to 3. So we can put the value of a as 3 upon m. So now we can again write it as, sorry, it will be, we have already taken the LCM. It means this is 3 upon m. So now we can rearrange it as 2m square minus 5m plus 3 equals to 0. It will be having two roots, m1 and m2. Since we are having two lines with two different slopes, m1 and m2. So let's say the slope of this line is m1 and slope of this line is m2. So from here we can write the slope m1 and m2. So let me write m is equals to minus b plus minus root over b square minus 4ac. This is 24 divided by 2a. From here we can write it as m is equals to 5 plus minus 1 divided by 4. So we can write m1 is equals to 5 plus 1, 6 upon 4, that is 3 by 2, and m2 will be equals to 5 minus 1, that is 4 upon 4, that is plus 1. So both the slopes are positive. So we can write the equation of tangent as Now we can substitute the value of m1, m2 in this equation. Y equals to mx plus a upon m. We can get two equations, and those two equations will be equation of two different tangents. So write the equation of tangents as. So we have assumed the equation of tangent as y equals to mx plus a upon m, and we have seen point P lies outside the parabola, and we have solved with, since we know point P will pass, so this line will pass through this point, and from here we got quadratic in m, and we know that point P lies outside the parabola. It means there will be two slopes, and we got the slope value as m1 as 3/2 and m2 as 1. So now substitute these values in this equation which we have assumed. From here we can write equation of tangent 1 as y equals to, let's see, 1 slope 3/2, so it will be 3/2 x plus 2/3 into a, that is 3. So y is equals to 3/2 x plus 2. This is one equation, and the second equation will be y equals to, and let's say m value is 1, so it will be x plus a is 3 and upon m is 1. So in this case y will be equals to x plus 3. So these are two tangents equations which are asked in this question. So let me summarize once again. This is the first question. So we have been asked to find the equation of tangent on the parabola y square equals to 12x, where we have been given that this tangent will pass through the point with coordinates 2, 5. So we have written the equation of tangent as y equals to mx plus a upon m, since we have already seen the derivation part, and we know this tangent will pass through point P, that is 2, 5. So we have solved with 2, 5, and thereafter we observed that we have got quadratic in m, and from there we obtain two results, two values of slopes, that is one with 3/2 and another one is 1. So we have again substituted these values in this equation to write the equation of tangent. So these are the two possible equations of tangent. So let's proceed towards second question. Our question is, find equation of tangent to the parabola x square equals to 8y passing through point P with coordinates as 8, 8. So let's see, we have been given parabola equation as x square equals to 8y. So in this case, our parabola will look something like this. X square equals to 8y. X square equals to 8y. Passing through point P 8, 8. So let's see first of all whether this point P lies inside, outside, or on the parabola. So our equation is S1 is x square minus 8y. Now put the value of point P in this equation. We can get 8 square minus 8 into 8. That is S1 is coming as 0. So since S1 is 0, it means point P will lies point P lies on the parabola 8, 8 something here. So let's see, point P is 8, 8. So the very best practice to write the equation of any tangent on the any curve, and if you are having given one point lies on the same curve, in that case we can use Cartesian form of tangent. So what we have to do, we can use the result t equals to 0 to write the equation of tangent in that case. So our equation is x square equals to 8y, since it is x square minus 8y. So we can write x square with xx1, we can replace minus 8 times, we can replace y with y plus y1 upon 2 is equals to 0. Since t equals to 0, now we can substitute x1 with 8 and y1 with 8. So we can write the equation of tangent as 8x minus 4 times y plus 8 equals to 0. On more simplification, we can write 8x minus 4y minus 32 is equals to 0. Again, we can rewrite it as y is equals to divided by 4, 2x minus 8. So this is our final equation of tangent, y equals to 2x minus 8 on the parabola x square equals to 8y on the point P with coordinate as 8, 8. So once we will see any point P lies on the parabola or any curve other than parabola itself, so in that case we can use t equals to 0 to write the equation of tangent, and we can substitute x square with xx1, y square with y1, x with x plus x1 upon 2, and y with y plus y1 upon 2, and xy with xy1 plus yx1 upon 2 to write the equation of tangent very easily. So in this case we obtain the result as y equals to 2x minus 8 as our equation of tangent. So let's see our third question. Our question is, find equation of common tangent of the two curve y square equals to 4x and x square equals to minus 32y. So this type of question has already been asked so many times in JEE. These questions are very important questions. So let's see how to approach this type of questions. So we have been given two parabolas, and we are aware that we can write the equation of tangent on y square equals to 4x. Since we have studied to write equation of tangent, so we can write equation of tangent what is this? So we can write equation of tangent on y square equals to 4x as y is equals to mx plus a upon m, where a is 1 in this case. In case of y square equals to 4x, a is equal to 1. So we can write y equals to mx plus 1 upon m. Since this is the equation of tangent on y square equals to 4x, it means this tangent is going to be this very same equation is going to be tangent on this parabola also, because we need to write the equation of common tangent. So in this case, we can, since we have parabola's equation as x square equals to minus 32y, now we will go with basic. Since this is line, this is a parabola, we need to solve this simultaneously, and we know that this is a tangent. It means on solving we will get single point of intersection, right? In this case, we can substitute y is equals to, we can solve line and parabola, solve line, that is equation number 1, and parabola that is equation number 2. We will solve line 1, so we will solve line and parabola. So we can write x square is equals to minus 32y. In case of y, in place of y, we can write this value mx plus 1 by m, mx plus 1 upon m. So now we can solve it as minus 32 mx minus 32 upon m. Now let's see how we can proceed here. We can simplify it. And we can write as, so since this, we can write the quadratic in x square plus x, it will be 32m plus 32 upon m is equals to 0. So we have observed the equation in x. Now this is the equation in x, and it will be having x1, x2 or two solutions. But in case of this question, we know this is a tangent. It means there will be single solution, that is d equals to 0, condition of tangency. We have already seen in the derivation also, condition of tangency. So we will write d equals to 0, solve d equals to 0. Let's see what will happen. So from here we can write d is equals to 0. So let's see, in that case we can write 32m whole square minus b square minus 4 into 1 minus 4ac. The value of c is 32 upon m. It will be 32 upon m, and this will be equal to 0 because we have been given that line is a tangent. So in that case, we need to put d equals to 0. So on simplification this, we can write 32 whole square into m cube, 32 whole square into m cube minus, this will be 4 2s are 8 and 4 3s are 12 upon m is equals to 0. From here we can rewrite it as, once we will take 32 as common, we can write 32m cube minus 4 is equals to 0. From here we can write 32m cube is equals to 4. It means m cube is equals to 1 upon 8. From here we can write m is equals to 1 by 2. So slope of the common tangent is 1 by 2. And we know the equation of tangent as y equals to mx plus 1 by m. So we can put the value of m as 1 by 2 in this equation. This will be our common tangent on both the curves, right? So our final answer will be y is equals to m will be 1 by 2 mx plus c 1 by m. So it will be 1 by 2. So we can write y equals to x upon 2 plus 2. So this is the common tangent on curve y square equals to 4x and x square is equals to minus 32y. So what we have done in this question, we have written the equation of tangent for parabola y square equals to 4x, because that we are aware about. We have derived the equation for that in that case. So we have written y equals to mx plus a upon m. The value of a is 1 in case of y square equals to 4x, right? So from here we got this equation as equation of tangent, and we know this equation is we have solved this equation with parabola x square equals to minus 32y, because we need to make this as common tangent for both the curves. So now once we will solve line and parabola, we need to know to write the condition of tangency. We know that d is equals to 0. So from here we have obtained the quadratic in x. We have put the d equals to 0. So from there we have solved and got the slope value, that is m equals to 1 by 2. And we know the equation of tangent. We have substituted the value of m equals to 1 by 2 in this equation. So we have to write the final answer as y equals to x by 2 plus 2 as our common tangent on both the curve y square equals to 4x and x square equals to minus 32y. So this is our final answer. So let's see our question number 4. The question is, if y equals to mx plus 4 is a tangent to both the parabolas y square equals to 4x and x square equals to 2by, then b is equal to, we have been given 4 options, and this question has already been asked in JEE Mains 2020. So on the very same format we have seen question number 3. So let's see how to approach this question. So we have been given two parabolas y square equals to 4x as well as x square equals to 2by. So we can easily write equation of tangent on y square equals to 4x as y is equals to mx plus a upon m, where a is equals to 1 in case of y square equals to 4x. So we can write y equals to mx plus 1 upon m. So if this is a common tangent on both the curves, it means this is going to be tangent for this parabola also. So we can solve this line and parabola as well. So again we have been given equation of tangent as y equals to mx plus 4, as we can see here. So now we can compare this and we can write the value of m. On comparing, we can write 1 upon m equals to 4. So from here we can say m, the value of slope is going to be equals to 1 by 4. So we can write the value of equation of tangent as equation of common tangent. So we can write equation of common tangent as y is equals to, the value of slope is 1 by 4. So we can write 1 by 4 into x plus 4. So this is our common tangent, and we know this is the tangent for this parabola also. So we have been given one line and one parabola, so we can easily solve to get the condition of tangency on line and parabola. Solve line, that is tangent, and parabola. Solve line and parabola. Parabola will be x square equals to 2by. From here we can say we have the parabola equation as x square equals to 2by. So we can substitute the value of y as 1 by 4x plus 4. So we can write the value of y as 1 by 4, that is x upon 4 plus 4. So we can solve it as x square is equals to x upon bx upon 2 plus 8b, and we can rearrange it as x square minus b upon 2 into x minus 8b is equals to 0. So now we have obtained the quadratic equation in x, and we know since we have solved line and parabola, it means to gain the tangent, to write the condition for tangency, we should know, that is, we need to write d equals to 0. This is the condition of tangency, because there should be one single point of intersection between line and parabola. So this is the condition of tangency. So from here we can say b by 2 whole square minus 4a into c value is minus 8b is equals to 0. From here we can say b square upon 4 plus 32b is equals to 0. From here we can take b as common. So from here we can say b upon 4 plus 32 is equals to 0. Now two factors, either b will be 0 or b by 4 equals to minus 32, but we can't take b equals to 0, because if we will take b equals to 0, then our parabola equation will become x square equals to 0, no more parabola. So we can say b upon 4 plus 32 equals to 0, and we can say b is equals to minus 32 multiplied by 4. It will be nothing but 4 2s are 8, 4 3s are 12, minus 128. So option C is our right answer. So why are we not taking the value of b as 0? Because it will become, x square will become 0, and we can't write the equation of tangent on x equals to 0, right? So in this case, we have obtained the value of b as minus 128. So what we have done, we have written the equation of tangent for parabola y square equals to 4x as y equals to mx plus 1 upon m, and we have been given tangent equation of common tangent as y equals to mx plus 4. From there we have compared and obtained the value of m as 1 by 4. And now we are aware about the common tangent and parabola x square equals to 2by. So we can solve it simultaneously, and we have got the quadratic equation like this. Since line is tangent to the parabola, it means d equal to 0 will hold the condition. So this is the condition of tangency. From here we can obtain that there are two factors for b, either b is 0 or b by 4 is equal to minus 32. So we have excluded b equals to 0, and we have included the answer of b by 4 equals to minus 32. From there we have solved b equals to minus 128 as our right answer and the final answer. So let's proceed towards question number 5. The question is, The tangent to the parabola y square equals to 4x at the point where it intersects the circle x square plus y square equals to 5 in the first quadrant passes through the point. We have been given 4 options and this question was asked in JEE Mains 2019. So we have been given that the tangent to the parabola, so we need to write the tangent to the parabola y square equals to 4x at the point where it intersects the circle this in the first quadrant. So let's draw a rough sketch for this problem. So we have been given one circle with center, origin and radius root 5, right? The radius of root 5, and we have been given one parabola also. So it will cut so the point of intersection of circle and parabola will be at 2 different points in the first quadrant as well as in the fourth quadrant. But we have been asked that we need to write the equation of tangent on this parabola on this point where it intersects the circle in the first quadrant. So we need to find this coordinate, this point P, right? So let's solve parabola and circle. So we have been equation of circle as x square plus y square equals to 5, and we have parabola equation as y square equals to 4x. We can substitute the value of y square equals to 4x in equation number 1. So what we can obtain, x square plus 4x equals to 5. From here we can rearrange it as x square plus 4x minus 5 equals to 0. And from here we can make 2 factors, x plus 5 into x minus 1 equals to 0. So 2 roots will be there, x equals to 1 or x equals to minus 5. But we need to take the point P as in the first quadrant. So we need to take x equals to 1 as the x coordinate. So put value of x equals to 1 in equation number 2. So we can say y square equals to 4. That means y equals to plus minus 2. It means since point P is in first quadrant, so our coordinates will be 1, 2. So we have obtained the point P as 1, 2 with its coordinate. Now we need to write the equation of tangent on the parabola on point P where P lies on the parabola itself and the coordinates are 1, 2. Since we are aware, if we have the equation of any curve and we know the point P lies on that curve, so we can use Cartesian form of tangent. So we can use t equals to 0 to write the equation of tangent in that case. So we have parabola equation as y square minus 4x. So we can apply t equals to 0 and we can write y1 minus 4 times x plus x1 upon 2 is equals to 0. So x1, y1 will be 1, 2 simultaneously. So from here we can say 2y minus 2 times x plus x1 is 1 is equals to 0. After simplification we can say y equals to x plus 1. Y is equals to x plus 1, equation of tangent. So this is the equation of tangent. This is the equation of the required tangent at point P 1, 2. So now we have been asked, this many 4 points have been given. We need to observe which point passes so which point lies on this equation, right? So let's see first options. First option is 1 by 4, 3 by 4. So once we will put the value of x as 1 by 4, we will obtain y coordinate as 5 by 4. So this is not our right answer. Let's see second option. Once we will substitute the value of x as 3 by 4, so 3 by 4 plus 1, it will be 7 by 4. So this is our right answer. So let's see other 2 options as well. So once we will put the value of x coordinate as minus 1 by 4, then minus 1 by 4 plus 1, it will be 3 by 4. So but here it is given 1 by 2. So this is also not lying on this equation, right, on tangent. So let's see fourth point. So once we will put the value of x as minus 1 by 3 plus 1, then y will be 2 by 3. But y coordinate is given as 4 by 3. So this is also not lying on this tangent, right? So option B is our right answer, 3 by 4, 7 by 4. So what we have done here is, so we have been given equation of circle and parabola. We have solved this to obtain the point of intersections. Since we need to write the equation of tangent on parabola in first quadrant, so point of intersection in the first quadrant will be 1, 2. So we obtain the result. We obtain the point of intersection in first quadrant as 1, 2, right? From there we can write the equation of tangent by using t equals to 0, since our point lying on the parabola itself. So from there we can substitute y square with y by 1 and x with x plus x1 upon 2, and we have got the equation of tangent as y equals to x plus 1. Now we need to verify which point lies on this parabola, on this equation of tangent. So we have seen option B is our right answer. So let's see our next question. The question is, tangents drawn from the point minus 8, 0 to the parabola y square equals to 8x touch the parabola at P and Q. If F is the focus of the parabola, then the area of triangle PFQ is equal to. So this was also asked in 2018. So let's see our question, our rough sketch is, we have been given parabola y square equals to 8x, right? This is the equation of parabola as y square equals to 8x. So we have been given tangents are drawn from point minus 8 comma 0. So it is very obvious that minus 8 comma 0 is lying outside of the parabola, right? From here, two tangents are drawn. Let's say tangent 1 and this is tangent number 2. So touches the parabola at P and Q. And let's say focus is a comma 0. So value of a will be 2 in case of y square equals to 8x. So 2 comma 0 will be our f. So we need to write the area of parabola, this one, P triangle PF1. Sorry, area of triangle PFQ. PFQ. We need to write the area of this triangle. So first of all, we need to find the coordinates of P and Q so that we can able to write the length of PQ and we can easily write the area. So what we need to do is, so if we have to assume any point P, any point, a random point or general point on the parabola y square equals to 8x, so we can easily assume the point P as 80 square comma 280 in case of y square equals to 4ax. So we have y square equals to 8x, it means a is equal to 2. So 80 square comma 280. So 2t square comma 40 will be our general point. So we can write the equation of tangent on this parabola, right, using point P. So we can write easily as ty equals to x plus 80 square as equation of tangent. Ty equals to x plus 80 square. So this is the equation of tangent on the parabola on point P with coordinate 2t square comma 40. So this is the equation of tangent. Since this tangent passes to the point minus 8 comma 0. So from here we can satisfy minus 8 point minus 8 comma 0 lies on this equation, on this line. So it will be satisfying in this. So from here we can write 0 equals to minus 8x, minus 8 plus 2t square. From here we can write t square equals to 4. That means t is going to be equals to plus minus 2. So from here t will be equals to plus minus 2. Since point P is, let's say, in the first quadrant, in that case we need to take value of t as positive because y coordinate should be positive. So if t is positive, then only y coordinate will be positive. So we know if t is equals to 2, so for point P, in first quadrant, t is equals to 0, right? From here we can write point P as 2 into t square comma 4 into 2. That is, point P will become 8 comma 8. So by using symmetry we can also write the point Q as 8 comma minus 8, or else we can take the, this point t equals to minus 2. T will be equals to minus 2 for point Q. So point Q coordinates will be equals to 80 square, that is 2t square comma minus 40. 80 square comma 40, and here we can put the value of t as minus 2. So it will be 2 multiplied by minus 2 whole square comma 4 into minus 2. So point Q will become 8 comma minus 8. So point P is 8 comma 8 and point Q is 8 comma minus 8. So we can easily see the length of PQ. So we can write the area of triangle PFQ. Area of triangle PFQ is equals to half base into height. Half base will be length of PQ, that is 8 plus this length is 8 and this length is also 8, right? So it will be 16 multiplied by this height will be, this is 2 comma 0, this is 8 comma 0, that is 6. So it means 6. So it will be 8 into 6, that is 48 square units. 48 square unit is our right answer. So what we have seen here, we have been given that tangents are drawn from point minus 8 comma 0. So there will be two possible tangents as point P lies outside the parabola. So we have done, we have assumed a general point on parabola, on point P on parabola with coordinates 2t square comma 40 or as a point P. Now we can write the equation of tangent on point P as ty equals to x plus 80 square. Since we are aware that this tangent will pass through point minus 8 comma 0, so we have simplified this with minus 8 comma 0 and we have obtained that t will be plus minus 2. In case of tangent, if tangent is passes through the point P which is lies in first quadrant, in that case the value of parameter t will be plus 2, and if it would have been -2, it means that this tangent will be passing through point Q on the parabola, right? So we have seen the coordinate of P as 8, 8 and coordinates of point Q as 8, -8. And from there we can see area of triangle PFQ as half into base into height. So this is the 16 length and height will be 6. So from here we got 48 square unit as our final answer for this question. So let me summarize for today's session. So what we have started with line and parabola, and we have seen there are 3 different cases where line will never touch or cut the parabola, or line will touch the parabola and that will be the tangent. And in third case we have seen line can be secant, that is it will be cutting the parabola at 2 distinct points, right? From there we have seen equation of tangents, and for that we have solved line and parabola and to obtain the condition of tangency. And we have seen that in order to write the equation of tangent, we should aware that d is equals to 0 will be our condition of tangency, because line and parabola will intersect at the one point, that is line will touch the parabola at single point. So in that case we need to use d equals to 0 as condition of tangency, and we have seen that c equals to a upon m as the condition of tangency to write the equation of tangent on the parabola y square equals to 4ax. So our equation of tangent will become y equals to mx plus a upon m. And thereafter we have seen different forms of equation of tangents, that is we have seen slope form of tangent, that as y equals to mx plus a upon m. And thereafter we have seen Cartesian form of tangent, where we have seen we can write the equation of tangent on the parabola if point P lies on the parabola itself by using the notation t equals to 0. To write the value of t, we need to substitute x square with xx1, y square with yy1, and x with x plus x1 upon 2, and y with y plus y1 upon 2. In case we have term xy in some different curves, so we can substitute xy with xy1 plus yx1 upon 2, right? So thereafter we have seen the third form, that is parametric form of tangents, and we have seen if we are given any point P lies on the parabola itself, so we can assume the point P as 80 square comma 280 in case of y square equals to 4ax, and then we can write the equation of tangent as ty equals to x plus 80 square. And thereafter we have moved towards the questions, and we have seen that highlights of tangent also we have seen, in which we have observed that if point P lies on the parabola, then there will be a single unique tangent, and if point P lies outside the parabola, in that case there will be 2 possible tangents. Other than this, if point P lies inside the parabola, in that case there will be no common tangent, there will be no tangent at all, right? So we have seen the problems also based on these concepts and equations of tangents. So also we have seen questions which where point P lies outside the parabola or on the parabola also. So to condition to check whether point P lies inside the parabola or on the parabola or outside the parabola is, we will put that coordinates of x and y into the equation of parabola. Once it is giving as 0, it means that point P satisfies the parabola, it means point P lies on the parabola. If it is less than 0, it means it is lying inside the parabola, and if it is positive, in that case that point P will lies outside the parabola. So we have gone through the questions and we have seen different forms of questions. We have covered all the topics, all the questions possible on this tangent and equation of tangents, right? So we'll move towards another problems. We will see different cases and we will see different topics as well in upcoming lectures. So revise all the questions and thoroughly and try to solve by yourself once again. We'll see you in next video. Till then, take care. Bye bye.